All right, today we're looking at Math 2 Unit 3, Lesson 1. This is your homework help that goes along with the lessons you'll be having in your class. This is Form K from the textbook. So here we go, looking at the first set of questions. It says each pair of polygons is congruent. Find the measures of numbered angles. And so it's a little blurry, I know, in the video to read here, but you have a 1 and you have a 2, and we're looking for what those angles are going to be. Because the pair are congruent, and I look here at how it's organized, I have a right angle in this corner, which makes my angle 1 equal to 90 degrees. And my corresponding angle for 2 over here is going to go along with that 40 right there. So angle 2 equals 40 degrees. It's as simple as that, looking for the matching parts. I'm going to look at the second one. Same idea, looking at matching parts again. I'm looking at this space right here, which corresponds to this corner over here. So angle 1 is going to be equal to 95 degrees. And then again, the second one is over here in C, which corresponds to the 60. So angle 2 is going to be equal to 60 degrees. All right. Numbers 3 through 7, it wants you to use the two triangles right here in order to compare parts. And so we have A, B, and C. You have X, Y, and Z. And what's important here is just to remember the order that things go in. So for example, when they ask you to compare set line segment AB, we're going to go in the order from A to B this way. Just like as in triangle, it goes AB in my written order. I'm going to go XY is my next one, so I would say that AB is congruent to line segment XY. And you'll do the same type of thing throughout the rest of these as well, as you compare the parts, comparing the different angles, the different lines there, or the different angles. So if you look down below, for example, at number 5, angle Z, which is here, is corresponding and congruent to angle C in the triangle next to it. Sorry, I messed it up there. So there's Z congruent to C. And again, you just go through the rest of them there. Let's look at the next one. This next section here, part 8, number 8 and 9. Again, what's important to remember is that order is important when you look at these kind of problems. They're basically saying I have a FOUR. We can think of that as being perhaps, if you choose, a square or a rectangle. And I can draw one here for you, and I can label it FOUR. And then I have a second corresponding or congruent square or rectangle, whatever you want it to be, called many. M-A-N-Y. So it helps you to visualize a little bit. That could help you there. It says, list down 4 pairs of congruent angles. Well, if I'm going to have 4 pairs of congruent angles, whatever it might be, I can have, for example, I could say that angle F is going to be congruent with angle M. Now I can write that down as angle F is congruent to angle M. And I could do that same thing for O and A, and so on. Same for the sides. If I want to find 4 pairs of congruent sides, let's say I wanted to take a look at side length OU right there. Okay, I could write OU and make that length there is congruent to AN on this side right there. I did it with a picture. It just helps me visually see what's going on. Again, as long as you follow the same order of your letters, you're going to be okay however you want to do that. When I look here at OU, because they are in the middle of my little 4-letter word there, and AN are there, then I'm okay. I wouldn't want to do NA because that's going the opposite way, and I just want to keep it the same order. All right, number 10 and 11 here. It says, see if you conclude the figures are congruent and to then justify your answers. It's asking, okay, are these similar shapes or are they not? For number 10, what we know so far is we can see that it has a right angle, it has a right angle, but it doesn't tell me any of the lengths of the sides. So while it might look the same visually, I can't verify whether or not it actually is the same because I'm not sure about what these sides are going to be. I don't know for certain because it didn't give me enough information. Later on, we'll learn that this angle and this angle are going to match because they're vertical angles, and that would mean that these angles are together, but as it stands right now, I don't have enough information to really conclude if they're congruent or not based upon where we are in Math 2 at this point. So for right now, we would say there's not enough information because the angles are we just don't know information about the angles yet. But later we might. Okay, number 11, we have two triangles, triangle ABC and then triangle FGH. Again, look at the order things are in. We have A with a 3, 2, 1, and we start with F and go 3, 2, 1, and we can see we have congruent parts on the second angle from FG, the second one, AB, we have the matching angle, and the third angle, we have a matching angle, so we have three matching sides, two matching angles at least. We can probably figure out, we're doing some math, a triangle is 180 degrees, that this one would also match because of what's available for it to be there, available for it. And in that case, we'd say yes, based upon what we call this is what's called the third angle theorem. We would say yes, that these are two congruent triangles. Because again, if I knew this was, I don't know, 45 and that's a 45, which is not, then we would add them up and then subtract that from 180 to find out what's left. And we recognize that, oh, we're going to be having the same angle there. So yes, that would be congruent based upon the third angle, plus the fact that all the sides are congruent. Okay, so that really is an indicator that these are congruent triangles. Let's look at the next page on the back side. Looking at number 12. All right, these problems are a little more challenging, and we're going to have lots of them in the lessons to come in this unit, where you're having to prove that certain things are true. Triangles are the same, or lines are the same. And so you're going to have to spend some time learning your different theorems and postulates. So for today, first we have, it gives us some information. It says that AD, this line right here, and BE, this one here, bisect each other, which means they kind of go across one another. When something bisects, one of the things it does tell us when they bisect is that we're going to have some matching parts here. Bisecting means it cuts it in half, essentially. So it gives some nice parts to work with. Okay? So, and it also tells me that AB here equals DE, and they mark that with a single line. And it tells me my angle A equals angle D. And we're trying to prove that this triangle, ACB, is congruent to DCE. That's the idea. So when we first look at it initially, what we can see is that we write down the given information. What they gave us here, AD equals and BE bisect each other. AB is congruent to DE and the angles, and we just say that it's a given. The next part is they say that AC, this line here, is congruent to CD, and they say that BC is congruent to CE. We would write that by saying AC is congruent to CD, and as a third line we would say BC is congruent to CE. And the reason we can say that is because this is the definition of bisect. So when we bisect something, it means we're cutting it in half into two equal parts. Okay, so it's just cut in half. So as a result, that part matches that part, and this part matches that part. Now we can look at it and it says, all right, angle ACB, and remember, the letter in the middle is the angle you're looking at, is congruent to angle DCE. So it's saying that ACB, this angle here, is congruent to DCE, this angle here. And that's going to be true that the two angles that are across from each other and that share the same vertex, sorry, wrong word there, are going to be the same, and that's because of the vertical angles are congruent. And that's how you'd write that out. Because vertical angles are congruent, they're going to be the same. As a result then, now we can say that, well, we have an angle, we have three sides the same, we have another angle the same, we have one more angle over here, and it says, oh look, angle B is congruent to angle E. Well, is that true? Yes, that would be true, and we know that by the third angle theorem, which just means if I was to add these up and add those up, they would equal the same amount, and if I subtracted that from 180, it would tell me what B is going to be equal to, and it would be the exact same thing that E is equal to. Then our last part here says that a triangle ACB equals triangle DCE, and that is by given to us. The reason is it's the definition of congruent triangles. Definition of congruent triangle says that if I have three equal sides and three equal angles, then it's a triangle and they are congruent. So that's what number 12 looks like. Let's slide on down to number 13. 13 is a little different here. It tells us, it says, if triangle ABC is congruent to JKL, which of the following must be a correct congruent statement? Again, like we said on the previous problem, the order is important as you do this. We want to keep the order in mind. So, we look at our triangle here. A comes first, all right, and our next letter is J. Well, it says that angle A is congruent to angle L. That's not the right order. That's number 1 going with number 3. So that's not going to be true. Next it says AB, which would be like here, AB, is congruent to JL. If we look here, those are not side by side in that order idea. So that would not be true. Our next one, C, angle B, that's the one in the middle, is congruent to angle K. Well, those are both in the middle, so that looks like it's going to be true so far. And then finally, BAC, which is B, A, and then all the way around C, congruent to LKJ. Well, we're starting at a different spot. I'm starting here at the second one and going backwards, and here I'm starting at the third one going backwards. It's the wrong order, so that's not going to be a congruent statement because order does matter when we're working with these things. Let's go to number 14. Number 14, it says, a student says he can use the information in the figure to prove that triangle ACB is congruent to ACD. Is she correct and explain? So he wants to say, or she wants to say that ACB equals ACD. And one of the things I just said is what? Order is important. And if we look here, if I start at A, I have angle number 1 basically, is one arc right there. And I'm good for that one. And then I'm going to the second side over here. But over here on this one, this angle, triangle ACD on this side, this angle is a 2-arcer, right? It's different than this angle. As a result, these are not the same if you go in that order. It's not going to work. You could work if you wrote it a different way. I could say that A, B, C, going from 1, 1 to 2, A, B, C, might be congruent to, let's see, 1, 1, 2, 2, yep, triangle C, D, A. That would be a true statement, but that's not what they're asking. All right, coming up to our last ones here. Number 15, it says find the values of the variables, and these are a little smaller, so I'm going to zoom in a little bit for you here because I know they're a little small to see. Even that's not very good. The autofocus maybe? Nope, not much better, so I will rewrite these here. Okay, we have, let's start with our values in the bottom. We have 9 inches in the bottom of this guy, and I have right here 3x. Because it tells me these are congruent already, I can say that 9 is equal to 3x and solve for x. So I just set up the equation, 9 equals 3x. I divide both sides by, what's holding together, 3. 9 divided by 3 is 3. And 3 divided by 3 is 1, so I'm left with x equals 3. To find the y value, this angle, it tells me, is 30 degrees, and this angle is 2y degrees. And again, because they're congruent already, I can use that information to help me solve for y. And I set up an equation. I said 30 equals 2y. To get the y by itself, I will divide both sides by 2. 30 divided by 2 is 15, and that equals y. Now, that's all I got to do. So I have my 15 for y, my 3 for x. Looking at number 16, same idea. For number 16, for this one here, I have what are known as alternate interior angles. Kind of important, remember that it comes up a lot in this unit. That means I have an angle on this side, and this angle here is going to be equal to this angle here. It's called alternate because I'm like going every other inside-outside type thing. I'm on this side, the right, and I'm on the left, and I'm on the right, and the left. So it's alternating the side that it's on, and it's also on the interior of the shape. That means they're going to be congruent. So I can set up an equation to say 75, this angle here, equals 5x, and solve for x. To solve for x, I'll divide both sides by 5, and x is going to be equal to 15 for my answer for number 16. Let's take a look at two more here. Number 17, it tells me that the measurement of angle F is this, and measurement angle Q is this. If I look back at my triangle, where it tells me this, where they're congruent, F is my first one, Q is my second one. So basically, I already know that the measurement of angle F equals the measurement, congruent to, the measurement of angle Q, based upon my triangle information. So now I can take my two little equations, here and here, and I can rewrite them in place of the angle measurements and say, all right, x plus 24 is equal to 3x. And now I can solve for x. So I can subtract x from this side, subtract x from this side, and I'm left with 24 equals 2x. Divide both sides by 2, because that's what holds them together. And I'm left with x equals 12 for that one there. For number 18, right beside it, same idea. Again, I know that from the previous little triangle picture up above that GH is equal to RS. So I'm going to use that information over here. And so I can set these two little equations equal to each other. I can say 3x minus 2 equals x plus 6. I can subtract an x from both sides. So now that I have 2x minus 2 equals 6. I can add 2 to both sides, and now I have 2x equals 8. If I divide both sides by 2, I find out then that x equals 4. And I think I did something wrong. Nope, I'm okay there. Oh, you know what I didn't do? It wants to find the measures. I apologize. Let me back up a little bit here. It says find the measures of the given angles or the lengths. So let's finish this one real quick because I wasn't done yet. That's just the value of x. So the length of that segment is going to be, if I plug it back into the equation, RS, for example, will be equal to 4 plus 6, which is 10. So RS is going to be equal to 10, and so will GH be equal to 10. I need to make sure I plug that back in. So I'm going to slide back over here. Sorry if I went too fast there before. I need to plug my 12 into one of my equations. So I'll plug into this one. 3 times 12 equals 36. So the measurement of that angle, angle F and angle Q, are going to be 36. That's my final answer. Sorry about that. Okay, and that's today's lesson. Hope that helps some.